Hello friends, welcome to engineering tutorial. Now in my previous videos I discussed about the concept of transistor biasing and discussed about the various ways or methods how to bias a bipolar junction transistor. Now whenever we approach a circuit, a biasing circuit involving a bipolar junction transistor, the concept of KVL always comes. That is, we have to determine the collector current and the collector emitter voltage, the output current and the output voltage. Now, some students, they always have confusion related to how to apply KVL in a circuit. So sometimes they make mistakes such as putting the wrong sign convention or changing the polarity or how to apply KVL from a particular point. So there is some confusion related to application of KVL among students. So I already posted one video related to KVL about the various approaches of applying KVL, the first sign dominating method and the second sign dominating method. Here I have tried to elaborate this application of KVL and how to apply KVL in a circuit. Because we are discussing the transistor biasing concept, it involves KVL a lot, where we have to apply a lot of KVL. So for that purpose I have tried to elaborate that KVL topic so that you understand the basic concept about KVL and the application of KVL in a circuit in a better way. Okay, so let's get started. Now there are basically two ways to apply KVL. I have already taught you about the first sign and second sign dominating method. That is the basic approach of applying KVL. But in a closed circuit, there are two ways in which the KVL can be applied. It depends on how the circuit is represented. Okay, so basically there are two ways in which a KVL can be applied in a circuit. The first one is the point to point KVL. The second one is the ground to ground KVL. Okay, now before going deep into this, now let us see how the various circuits are represented. Okay, this is the base resistor biasing circuit. Okay, you have already seen my video related to base resistor biasing. Okay, so this is the base resistor biasing circuit. This is one way of drawing the base resistor biasing circuit. The other way is like this. Okay, both these circuit diagrams are the same, but these are just different ways of drawing the same circuit. Now you see here both these endpoints of RC and RB are connected to VCC. VCC means plus VCC, that is the positive end of VCC. So here also both the ends of RB and RC are connected to positive terminal of VCC. The emitter terminal is grounded, so here also the emitter terminal is grounded. And the other ends of the resistances are connected to the base and collector terminals. Here also this is connected to the collector terminal, the RC, and this is connected to the base terminal. Okay, so these two circuits are the same. Okay, this one and this one. These are just different ways of representing the same circuit. Now, whenever you see this sign plus VCC, whenever a point is connected to plus VCC, it means that it is connected to the positive end of the supply voltage VCC and the negative end is connected to ground. Okay, the plus VCC means this end, free end, is connected to the positive end and the negative end is connected to ground. This essentially means this. This is the equivalent, okay, of this symbol. Plus VCC means this free end is connected to the positive end of VCC and the negative end is connected to ground. The supply voltage always has a ground. Okay, we don't generally do not draw the ground, because we think that the students, they know that there is a ground connection, but sometimes students get confused about the ground connection. So always every circuit has a ground, be it the supply voltage or the reference connection, because it provides the reference. Okay, so always whenever you see a supply voltage, you have to keep it in your mind that it has a ground connection. Okay, this means this end is connected to positive, negative end is connected to ground. Now whenever you see minus VCC, okay, whenever something is connected to minus VCC, it means that this free end is connected to the negative end of the supply voltage VCC, and the positive end is connected to ground. Okay, this is just the opposite of this. Here the free end is connected to the positive end, the higher size bar of the supply voltage. Here this end is connected to the negative end of the smallest size bar of the supply voltage. The magnitude of both these supply voltages are same, VCC, VCC, but only the sign conventions are different because of the connections to the positive end here, and here it is connected to the negative end, and there is a ground connection connected to the other end. Okay, minus VCC means this free end is connected to the negative end and the positive end is connected to ground. So this is the this representation is the equivalent of this symbol. Now ground to ground KVL. Now what the ground to ground KVL essentially means, that you apply this KVL equation from one ground symbol to the other, continuously from one ground symbol to the other, by following this path in one direction. You do not repeat it. Okay, you just follow it, this from one ground to another ground, you just follow it continuously in one direction. Okay, here this circuit, this is essentially this one. Okay, this base resistor biasing, this circuit representation we have used, this is best suited for applying the ground to ground KVL. This VCC means it is connected to the positive end and there is a ground connection. Okay, there is a positive connection connected to it, the negative end is connected to ground, and there is a ground which is connected to the emitter terminal. The emitter terminal is grounded. So here there are two loops, the base emitter loop and the collector emitter loop, which means there will be two KVL equations. So here the ground to ground KVL is applied from this ground to this ground. So the KVL equation will be using the second sign dominating method. You know, my style is always the second sign dominating method, which I have discussed about in the KVL basics part 1 video. So please check out that video. Now here if we apply the KVL, it will be something like this: VCC minus IBRB minus VBE is equal to 0. This is the second sign dominating method, VCC, minus IBRB, the voltage drop across this base resistor RB, minus VBE, which is the voltage across the base and emitter of the BJT, and this ground is reached, so we get finally 0. When we apply it in the collector emitter loop or the output loop, it will be VCC minus ICRC minus VCE is equal to 0. Okay, so this is the ground to ground KVL. Next is the point to point KVL. So here in the ground to ground KVL, it is always applied from one ground connection to the other ground connection, traveled in one direction continuously. Next we have is the point to point KVL. Now the point to point KVL is for this second representation. Okay, this circuit. For this type of circuit, when a circuit is represented in this way, so you can apply the point to point KVL. It is best suited for this type of circuit. Now again pay attention that both these circuits are the same. Okay, only the representations are different, but they are essentially the same. So whether you apply point to point KVL or ground to ground KVL, the KVL equations will be the same. There will be no difference, but it is only our style, our approach, how we find it comfortable. Depending on that, you select a particular method of applying KVL. So for this circuit, the point to point KVL is best suited. What is the point to point KVL? It means that you start and end at the same point. Okay, suppose you start from VCC, from this point, so you complete one direction, follow it in one direction, whether it is clockwise or anti-clockwise, until you reach that point. But do not include again, do not repeat the same. Okay. So suppose you start from here, from VCC, using the second sign dominating method. I have used the second sign dominating. It will be VCC minus IBRB minus VBE is equal to 0. So VCC minus IBRB minus VBE, you reach here up to VCC. Do not again include VCC. Okay, so here we have moved in clockwise direction. You can also move in anti-clockwise direction. There is no problem. It is only on your level of comfort, whether in which direction you want to go. Similarly, here we have moved in anti-clockwise direction. We have again started from VCC. So here VCC minus ICRC minus VCE is equal to 0. So if you see, the KVL equations are the same, no matter what is the KVL method, whether it's point to point KVL or ground to ground KVL. The KVL equations will always be this. Okay, so it's only which representation, circuit representation is used. When the circuit is represented in this way, it is best suited for ground to ground KVL application. When the circuit is represented in this way, it is best suited for point to point KVL. Again, in point to point KVL, if you start from this, let's say from here, so the KVL will be like minus IBRB minus VBE plus VCC is equal to 0 until you reach this point. But do not include this again. Again, you can start from here, but you have to end here as well. Okay, you can start from this point plus VBE point, you have to go and reach the same point, but do not include it, but do not repeat two terms. Okay, there will be only one unique term in a KVL. So it only depends on whether the circuit representation in this way or it is in this way. So according to that, you have to see which type of KVL you want to put. So whenever you apply KVL, there should be few things that you must be clear about. Whether you are using the first sign or the second sign dominating method. About the first sign and second sign dominating method, I have already discussed in my previous video related to KVL in part 1. Next, you have to see whether the circuit is drawn in this way or in this way. Both these circuits are the same. These two circuits are the same. Okay, so if you find the circuit in this way, it is best suited for application of ground to ground KVL from one ground to another in one direction. If the circuit is drawn in this way, it is best suited for application of point to point KVL in clockwise or anti-clockwise direction according to your comfort level, according to your choice. Okay, so always you have to take these subtle things into consideration so that you do not make any errors while writing the KVL equations. Now again, I am stressing this point that whether the circuit is in this way or this way, whether you are applying ground to ground KVL or point to point KVL, the KVL equations will always stay the same. There will be no difference in the KVL equation. Whether it's the first sign or the second sign dominating method, whether it's point to point KVL or ground to ground KVL, the KVL equations will always stay the same. There will be no change in these two expressions. Okay, so it's only our way, our approach, whether in which approach we find it easy, we find it comfortable, we have command over it. So that is important. Okay, so here we have discussed about the various ways in which KVL can be applied in a circuit depending upon the various representations of the circuit. Okay, so we have two ways in which we can apply KVL, that is the ground to ground KVL for this type of circuit representation and point to point KVL for this type of circuit representation. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical and electronics engineering. Have a great day.